And we're live. Hi, everyone. Thank you so much for joining us again for another on .NET Live. My name is Cecil Phillip, and today we're going to learn about how we could write end-to-end FSharp applications using FSharp, using Azure Functions, using a really cool framework called Phillip that runs on top of Fable. Like, we're going to have all the FSharp things coming into us today. And my good friend here, Aaron, who's one of my teammates, is going to talk to us all about it. So, Aaron, why don't you really quickly introduce yourself to folks? Let us know who you are, where you're from, and what do you do?
Cool. Thanks for having me on. As Cecil said, my name is Aaron Powell. I work in the advocacy team at Microsoft as well, and I am in the JavaScript advocacy team. But before I got all into JavaScript and that everything became JavaScript-centric, I was a .NET developer. I started doing things like web applications in C# and all that sort of stuff. But about a decade ago, I got really interested in this F# language that was kind of on the fringe of .NET. And I decided to have a play around with it and fell in love with it straight away. So I've been doing F# for around a decade now, toying away with different ways to use F# and different like styles of applications to build and things like that. But at the end of the day, I build web applications. That's a lot of what I build. So I always wanted to work out what's the best way to build web applications with F#. And particularly as we move to doing more front-end centric web applications, how do we do those? How do I bring the stuff that I love about like a single page app that's running entirely in the browser, but not have to do that just with JavaScript? Because we all know the challenges that JavaScript can bring to web app development.
Right. So, Aaron, you mentioned a little bit that you have some familiarity with building things with .NET. Did you have any experience building anything with functional programming languages before you got into F#, or was that also like a new space for you to wrap your brain around?
No, it was very much a new space for me when I got into F#. Like I did things like C and C++ and Java at uni, and when I got out of uni, my first job was doing classic ASP and VB script and then C# development. I've never used languages like Haskell or Lisp or like those sorts of languages where you might consider a bit more esoteric and stuff like that. I don't know what it was about F#. Like I'd always dabbled in kind of these weird .NET languages. I did a bunch of stuff with Boo. Shout out to anyone that's listening that is actually familiar with the Boo programming language for .NET. I did a bunch of stuff with that back in the day. And yeah, like F# just kind of fitted that niche of I don't quite know what I'm doing, but it's interesting and it's still familiar at the same time, right? Like it's still .NET at the end of the day.
Yeah. That reminds me of before I used to play around with like Iron Python and Iron Ruby, right? Before I knew Python and Ruby, I was just like, oh, okay, well, I already know .NET. Why can't I'll pull another language in with some of the libraries I already have, and hopefully I can figure out how it works. So I totally get that.
Yeah. I remember playing with those back in the day. There was actually an Iron JavaScript. Someone wrote a DLR version of JavaScript, and they wrote it entirely in F#.
Okay.
It was one of the most complex things I remember first seeing. Yeah.
That's crazy. So Aaron, one of the things we like to do is always acknowledge like where our audience is calling in from or where they're watching from. And I know you're in Australia right now. You might tell us like what part of Australia that you're in at the moment?
I'm in Sydney. We're actually in lockdown at the moment. We're having some pretty bad COVID outbreaks at the moment in Sydney. So my kids might wander in because we're homeschooling and all that kind of stuff. But it's also like 7 a.m. So if I just fall asleep at like partway through this, it's not because the content's not interesting. It's just that it's 7 a.m. Like this is like it's way too early. And you can also watch the sunrise through the window over my shoulder.
Nice. And so for me, I'm calling in from, or I'm streaming to everyone from Florida. So I'm actually in the middle of a thunderstorm right now. And I was telling Aaron before we started, if I disappear for a brief moment and my power gets cut out because there's tons of lightning and thunder and all kinds of stuff happening outside my window, I apologize. I'll be back as soon as I get power back. But I'm just saying to folks that might happen. But Aaron is going to be here to take care of you in case anything happens to me. And then looking in the
proof
chat,
that this will be live.
Exactly, it's proof that this is live streaming. Right, this is not a pre-recorded session. I kind of just checking in with the chat real quick. So we have some folks here from Turkey, There's someone here from Austria. We have some folks from Algeria. There we go. We have some folks calling in or watching here from the UK. I know we always have folks from South America and Africa. Here we go. We have some folks from Norway. Again, we always like to just give a quick shout out to all the countries that are here that are watching. We appreciate wherever you are, whatever your time zone is. I know it might be either super early or super late. So there we go. Here's Jose. Jose's from Brazil. We have some folks from the Netherlands. We have Ukraine here. Again, like we have tons of folks that are really interested in learning about what we're talking about today. So that's always cool. There you go. We got Thaddeus from Nigeria. Again, definitely shout out to all the different countries that are here that are watching us. All right. So now, before we move forward and we start talking about all the stuff that you're going to show us, I want to share my screen and share a couple of links for some things I think that might be interesting to folks. So I'm going to pull up my screen really quickly, and a couple of things that I want to share with everyone. So first of all, if I can get my screen up, there we go. Oh, that's not my screen.
That's my screen.
How can I get my screen? There we go. There we go. All right. So first thing I want to share. So we have one of our MVPs, one of our really good MVPs. His name is Mark. He has this repo that's on GitHub. There we go. I was trying to zoom into it. Called Azure Functions University. And I think this is a recent project he just started, but pretty much it's a project. It's open source. It's online. That you could kind of come in and learn everything you need to learn about building apps with Azure Functions. There's some videos that are associated with it. So definitely go over and check out Mark's channel. And then, as you can imagine too, there's tons of code. There's lessons here. I think it even used like the Tours extension, the Code Tours extension. So if you open it up in Visual Studio Code and you have that extension installed, like it'll kind of walk you through those lessons, which I think is definitely pretty cool. So definitely check this out. As always, I'll make sure I share the links in the chat, like as soon as I'm done showing all of these, but definitely want you to make sure you know about Mark's little project that he has there. Another thing too, so I don't know what most of you folks are familiar with, but I'm not familiar with FSharp at all. So I'm really glad that Aaron's here to kind of walk me through, some of the things that we could do with it. But if you want to learn about FSharp, folks always tell me the best thing to do is to come here to fsharp.org and click on like that learn icon that's in the top menu. And there's tons of stuff, tons of, the mentorship program, the speakers program, you can read the language spec. You can just click learning FSharp. And then you can see tons of resources here that you can kind of go through. If, again, you're not familiar with FSharp, but maybe you might know some Java, some JavaScript, some C#, some Visual Basic, some other language, and you kind of want to get to know what FSharp's all about. So again, that's fsharp.org, and you can click on that little learn menu item at the top in the navigation bar. And last but not least, on July 29th of this month, we're going to have a .NET Conf Focus event. This one's going to be, again, on July 29th. It's going to be all about FSharp. So we have tons of great speakers, tons of great demos and announcements and all kinds of cool stuff with folks that are either working with FSharp, either in their own projects or on the FSharp team here at Microsoft. They got to tell us tons of cool stuff and show us lots of great demos. So if you're interested in FSharp, you want to learn more about it, or you want to see what other folks are building with it, definitely make sure you come over to focus.netconf.net. You can click on this little save the date icon, and you can make sure you join the conference. Also, this is a free conference, folks. So this is not something you got to pay for. You don't have to, do anything special. Like you just got to show up, right? So again, make sure you save the date and make some time on July 29th. Okay, now with that being said, this is why I always say, like, now this turns from the Cecil show to the Aaron show, right? It's not about me, it's all about you. So Aaron, why don't we kind of start off with talking about, if I'm interested, like I'm FSharp curious, and I really want to know, like, what can FSharp do? Like, can I build end-to-end applications with it? Can I build data science apps with it? Can I build web apps with it? Like, what are the things I can do with FSharp? Like, could you, I don't know, talk to us a little bit about that and show me maybe some things that we could probably do and places we could look at?
Yeah, for sure. Sorry, excuse me. FSharp is like being a .NET runtime language. You can do anything you could do with C# or VB.NET. You can do all of that with FSharp. The difference is that it takes that functional programming approach. So it has a bit of a different mindset to the sorts of things that you might be building. So you think more about the data modeling that you're doing and the types that you're representing and how you use those to build an application, rather than like necessarily the classes and this and the interfaces and things like that. You might kind of focus more on in a C# application. I'm also probably going to do some analogies with C# because that's kind of I think that's the one that most people resonate with from a .NET standpoint. But the difference with FSharp is that it's been open source for a really long time. It was the first .NET language to be open source from Microsoft. And because of that, there's a really strong community around it and doing things that really push the boundaries of what you might be able to do with a programming language that's meant to run on .NET. It was the first language that was really well supported to run on Linux. So I remember being at a conference a couple of years ago talking to an FSharp developer, and they had literally never used Windows. They always ran FSharp on Mono. And they were doing all their development on Linux. And yeah, it was like, yeah, like we wanted to use a functional programming language. FSharp fit the kind of model that we wanted. But I didn't want to run Windows, so I do all of my stuff on Mono, which is for me, that was kind of mind blowing because this is back before .NET Core and like everything was .NET Framework. I'm like, I never considered that there's people out there that are building .NET applications that don't run Windows, had never run Windows and stuff like that. And so, and as a result of that, people have pushed it to the point where what we're going to talk about today of like running FSharp just like purely within the browser.
Yeah, that's going to be really interesting to see.
Yeah.
So when you think about functional programming, because I'm going to assume, I know it's not good to make assumptions, but I'm going to make an assumption that a lot of the folks that are watching us today probably are familiar with object-oriented principles, object-oriented languages, C++, Java, C#, so on and so forth, maybe even a little bit of Python, but not so much so about functional languages. Like how much, I don't want to use hard, but like how easy is it for us to like adopt this way of thinking? Like, is it a completely different way of looking at applications? Are there some things that transfer? Like how much do I have to like unlearn some of the things I know and learn some new things?
Yeah, there's definitely a bunch of unlearning that you need to do because when I would come from C# programming, you think about so I create this class, and inside of that class, I'll have methods on that, and then I'll have properties on the class as well, and that's like how I do data interaction. Whereas in F#, well, like it compiles down and like you still have classes and stuff like that under the hood because that's that's what's run by the CLR. You're more thinking about what is the function that I need to do here. So if we're doing data transformation, I might create like an ETL class inside of C#, and then I'll create some data transfer objects, so just like some lightweight classes which represent those data structures. Well, in F#, I'd still create a data structure that represents that. We call it a record type in F#, which is similar to a record type in C#, but they have some slight differences. So let's not get into all of those specifics. But then you would create a function that takes the arguments in for what you need to do and then returns out the result. So we don't end up creating these classes around it and stuff like that. We just have a data structure and a function that takes some data as an input and gives you an output. The other thing that is really, I guess, a different set of mindset to of like an OO programming model is that you tend to write functions that we have that don't have side effects. So a side effect function is where it might be reaching outside of itself to modify some data or to get some additional information. In JavaScript, that's like reaching outside of the closure scope and stuff like that. In an F# function, we tend to pass in everything that's going to be needed for that function to operate, and it will do its operation and will give you a new result back. So even if we're doing, like we're updating some fields of a record, well, we're not going to return you the original record you started with. We're going to return you a new record. So you end up not changing a lot of data state. You end up with new state continuously as we go through. So yeah, that's where it starts becoming really I guess, mind-bending, because it's like, well, hang on a sec, can't I just set the property of this? It's like, no, you can't set properties because everything's like immutable and stuff like that.
Got it. And we got our first question coming in from YouTube, and I want to make sure we got to this before we get to the content you wanted to share. And this is from Jose, and he's asking, Aaron, I can't understand what is monads. When possible, could you explain what is monads?
The short answer is no, I can't. I honestly don't know what a monad is. And like I said, I've been dabbling with FSharp on and off for the better part of a decade now. Yeah. And I just like, look, it's something that I don't know. And it's not important to know to do functional programming. You can build suitably complex, like very positive FSharp applications and not have a single clue of what a monad is, because that's what I do. Right. People have tried to explain it to me in the past, and my eyes just kind of glaze over. I'm like, sounds good. Yeah. So sorry, Jose. I can't help you with that question. I'm sure that if you jump on the FSharp Slack channel, I think you'll get the link off the fsharp.org site that Cecil shared earlier. Yeah, you can ask someone there, and they'll probably be able to give you a very good, insightful answer that I can't.
Got it. And you know what's refreshing about your answer is the fact that I don't have to know monads, because I've heard it mentioned a couple of times, and I've had the same reaction as you. I was just like, "What are we talking about right now?" Like, I'm not sure what this is. So that's definitely good, to a little bit reassuring to know that we could still be successful and not have to do it. So Aaron, why don't we head over to your screen and start talking about like building some of these, like, you know, using FSharp to build some of these end-to-end scenarios. So I'm going to pull your screen up right now, and so let's talk about it.
Cool. So I thought I'd start with, like, what are we going to talk about building today? Well, we're going to try and build a web application. One of the things that I've been doing a lot of work with for the past sort of 18 months is the Azure Static Web Apps. Now, I know that you've had a bunch of people over the past months talk about static web apps, so I'm not going to spend a huge amount of time explaining what it is. But fundamentally, it's a way of hosting a front-end web application, generally something that's running just HTML, CSS, maybe some JavaScript, has images and things like that. It could be running a WebAssembly application like Blazor and whatnot. But then we can combine that with an Azure Functions backend. So where we can deploy this is where we would deploy our HTTP endpoints. So things that talk through to like Cosmos DB to get data out and stuff like that. So as someone who does a lot of stuff with static web apps, I'm like, okay, well, how do we build a web app that could be like end-to-end FSharp to deploy into here? And we can go down the Blazor route. There's an implementation of Blazor called Blero, which is for FSharp. I haven't done much with that because I tend to stick more at like the JavaScript end of web applications. So, well, what's our option there? Well, that's where we have Fable. So Fable, as I said, the community has really taken FSharp and seen like how far they can push it as a language and as a runtime. And Fable, I think, is the perfect encapsulation of that. Fable is a cross-compiler of FSharp to JavaScript. Yeah, so you write FSharp code and end up running JavaScript. That, like, I try to explain this to people, and they're kind of like, I don't understand why you would do that. I'm like, but you can. And there's a lot of valuable things that you can get out of doing this. And we'll see sort of as we do this kind of like and go and build an application. And there's a lot of companies out there that are using this to do end-to-end web applications, because like for me, one of the big things of this is that we can do like type sharing. So if I've got like a HTTP endpoint where I'm returning some data out of that, I want my client to understand what the data structure is that it's going to be receiving. And I kind of want that type safety. So if I add a field in the backend, I want the client to also know that field exists. Or if I rename something, I don't want to wait to a runtime error and then we've tried to unpack a JSON payload and things just go boom because it's JavaScript and it's runtime. I want a compiler that can help me with that. And I want to do it in a .NET way because like that's the programmatic interface that I want to use. So, fundamental question: how do we get started? How are we going to build a web application? I've gone ahead and created a couple of GitHub repo templates to make this easier to get started. So we've got three that I've created. One which is a Fable template. So Fable this is the bare bones of building a Fable web application targeting static web apps with an Azure Functions backend, again written in FSharp. But if you're building a complex web application, you're likely to want to use some sort of a JavaScript framework or some sort of web framework to make this a little bit easier. So I've created a couple of others for that. One which is using Elmish. Elmish is a implementation of the Elm pattern for applications. So this is a model view update process, and it's very functional programming centric and focuses on building applications in that very functional programming mindset. It uses a sort of a React-like experience to the way that you would be building an application. It can be quite a bit more complex for how you go ahead and like build these sorts of applications. So instead, we're going to use the third template that I've built, which is using a Fable library called Phillip. Phillip is a React DSL written in FSharp. Again, these are all open source projects that I'm going to be building on top of. So like this is stuff that the FSharp community has built, which is fantastic. And I want to highlight the amazing work that the FSharp community has done to make this sort of stuff so much easier. I'm just a mouthpiece for them at this point. But nice. Phillip is a way that we can do React and FSharp entirely end-to-end applications.
So quick before we continue. So as you can imagine, folks are just like F#, JavaScript, like what are we talking about? So this is one question from YouTube. So it's like JavaScript. So why use F#? So I guess the question is, if you're going to be generating JavaScript anyway, why would I want to use F# for that experience?
Yeah. Look, and that's a really valid question. Like, why would you want to go to the point of, like if you're compiling down and you got to run JavaScript in the browser, like, why use F# or why would you use Flow or TypeScript or anything like that? It's about, for me, it's about getting that type safe nature. I've done enough JavaScript programming to know that JavaScript can be a really painful language for a lot of complex applications. Just like lack of type safety, the way the language works and stuff like that. The other is from a functional programming standpoint, there's a lot of value that functional programming can give you in the way that you can build an application and design for applications. The fact that F# is immutable by default, so things that you, like I said earlier, you don't create data objects that you then change. You create new data objects from existing data objects, so you don't change the original one, you create a new one. And having immutable data can make it a lot easier to understand how data changes in an application. This is one of the reasons why React has always been popular for me, is that I can trace back to, if data has changed, this is where it changed, because data can only change in a very small amount of places. And F# gives us that sort of experience in the browser. And yeah, look, it's not going to be for everyone. I can fully understand that. But yeah, if you're doing a .NET backend and you want to do that type safety through to your client, I think that this is a great way to tackle that.
And I think
yeah.
I'm sorry, go ahead.
I was just also going to mention like one caveat on the stuff. So I'm talking about F# as a functional programming language. You can still do object-oriented programming as well in F#. So because it runs on the CLI, we can create classes, we can create abstract classes, we can create interfaces. You can do all that OO programming as well. It's not as well suited to like true OO programming as you would get out of like a C# experience. Yeah,
and I think it's almost like a similar. Like you get some of the same benefits that we'd almost get like from Blazor. Fable and Blazor aren't the same thing, but it's from the perspective of why would I write another language other than JavaScript when I want to target a browser-based experience, right? And it's the same thing, right? Like maybe you're not familiar with JavaScript, right? Maybe you're familiar with F# or C# and that's the experience you want. Maybe again, like you said, the type safety nature of it. We have tons of tools for debugging and testing and all these other types of things that already are in the .NET ecosystem, right? And so, if you want to make use of all of these things, but still target like these browser-based experiences, then sure, like why not, right? Like give F# a try, give C# a try, use Fable or Blazor or something like that. And then you could have, the power of those those other languages outside of like, having to use JavaScript or TypeScript.
Exactly. Yeah. Yeah. And that's a really good point. Like if you're not familiar with JavaScript, maybe this is a better option because you don't have to learn another language to build an application. You can take that existing skill set to building like a rich web experience as well.
Yep. Yeah, exactly.
Cool. Well, should we build something?
Can we really? I want to see some code,
Yeah.
man, because I've never written FSharp anything. So I want to see some code. Like that'll be great.
Yep. Well, I'm just going to show you like the easiest way to get started with these templates that I've created is that, so I'm going to use the GitHub command line and we're going to create a new repository here. And I've gone ahead and pre-written a command. So this is going to, using the GitHub CLI, as I said, we're going to create a new repository. I'm going to make a public repository using the Feliz template. And let's just give it a description. We'll give it that name, set that as the default origin. There we go. And then git pull, git branch, and then we've just got to set the main branch. Git pull origin main. And then we can set the branch. There we go. Okay. And let's open this up in VS Code.
Nice. And I see you using
insiders my screens. Yeah, I use VS Code Insiders. Like none of this stuff that I'm doing is VS Code Insiders specific, but I use Insiders because I like to make my life more difficult by testing things that could potentially break when you're doing a live demo.
Nice. So since you're using VS Code, are there any particular extensions you're using for FSharp, or is it just like the default .NET?
Yes.
Experience.
Yeah. I'm using the Ionite extension for FSharp. Again, this is a community extension, and it's the best FSharp editor experience. Like no disrespect to the .NET team at Microsoft and the Visual Studio FSharp experience, but Ionite is fantastic in the way it works and what it does. So it's what I use defaultly. These templates also, they contain a dev container description. So if you're not familiar with that, in VS Code, we can run inside of a Docker environment. And this will set up all the dependencies that you need. It will install all the .NET packages and the node modules that you're going to need. It will install the extensions and all that sort of stuff and run it in an isolated environment. And of course, it's realized that there is an update to a Docker container. So now I'm pulling down a stack of Docker stuff. I should have done that before we went on air. So we might go to a demo that I've created earlier because, yeah, there's like hundreds of megs that's going to be pulled down.
But you know what we could do too, because I think these experiences, being able to show them live on camera is important. And again, folks, this is live, right? Like this is not, we're not playing around here. For folks that are, like you said, aren't familiar with dev containers, like this is what's going to happen the first time you run your dev container. Yeah, right? It's kind of like, the first time you run npm install, right? Like it's going to pull down the things that it needs to run. It's going to calculate, okay, well, I need to put down this container and I'm going to install this package and yada, yada, yada. But then after that's done, then now you have like that isolated environment that you could start building stuff in. And you could run it on, Linux containers on your Windows machines, which I'm kind of guessing, I'm assuming that's what you're doing. But then now what you're showing here, like if you look at line 18 through 24, you can see what Aaron has in his side of his configuration file is he's saying, hey, I want you to open this workspace in a container. And within this workspace, I want you to have these particular extensions. And what I love about that is that means that I don't have to have all the extensions installed in my VS Code on my machine, like raw on my machine. Instead, I can only have them, light up when they're inside of this container experience, which I think is pretty cool too.
Yeah, and it's a great way to prototype with new languages and new platforms that you might not be sure that, do I need to install like a Python runtime and like all of that kind of stuff because I want to dabble around with Python, or can I run inside of a container? Similarly with something like this project, well, which version of .NET are we running on? Like, are we running .NET 3.1? Are we running .NET Core 3.1? Are we running .NET 5? Like, do we need both? It turns out we actually need both to do this. but the dev container will install all of that stuff. So you get all of the right runtimes. Do I need Node installed? Well, because I'm going to be compiling JavaScript, maybe I do. So I get all of that ready. Yeah, so on and so forth. So yes, I do pretty much all of my stuff with inside of dev containers. But I just thought I'd bring that up because I think it's going to take a while. But let's just have a look at some of the code that's inside of this this template. So we'll start with Azure Functions. So we've got an Azure Functions project here. And if you're familiar with Azure Functions from a C# standpoint, I've just created a HTTP endpoint. So this is the trigger. It's called get message, and it will do the same as the C# one. I'll explain what the function does, and then come and look at some of the other stuff that's around it. So we've got our HTTP trigger attribute, where we've then defined the authorization level. So it's function authorization or anonymous or whatever we want to set. What is it responding to? It's responding to gets and posts. We don't have a customized route on here, so that's just set to null. And then that's being bound to a variable name called rec, which is then typed as a HTTP request. We then also have our logger that's coming in, and that's typed as an iLogger. Now, oftentimes with F#, we don't need to specify the types aliases for members of functions that we're creating. The main reason that we do that is if we're doing, well, at least the main reason I find doing it is when we're doing C# interop, just because the F# compiler can't quite understand all of the types in the fully expanded .NET SDK, so we end up having to do some typing that way. And then inside of this function, we're going to log out some information, check to see if the query string or the has a key named name. If it does, then we're going to create a sum. So this is an option type. Talk about that in a second. Otherwise, if it doesn't exist, it's going to be a none. And then we're going to read the stream body and just see if there is data there. And then finally, we'll generate a new message which will contain the name using some pattern matching. If you're familiar with C# switch matching statements, then it's similar to that. We're just checking if the name is has a value. If not, nest and nest and nest, assign that to a variable. And then finally, generate a string that we send out as a response. So I introduced a couple of F# specific types inside of that. The first is an option type. F# doesn't do nulls. Like nulls aren't a thing in F# programming. I mean, they're a thing because it's on the CLR, and the CLR does nulls. But in F# you don't create things that can be assigned to null. We tend to use an option type to represent something that exists or doesn't exist. So if an option type exists, it's sum of a value. If it doesn't exist, it's none. So we can then do matching using pattern matching on that, saying where we can match on some of an object or none of an object, and then perform our operations. That's similar to like if something was null, do this, otherwise do that.
Right.
The other stuff that we've got is you'll see, apart from the fact that we're not using like var, we're using things like let with an exclamation mark. And we've got this weird looking character that's sitting after a command and stuff like that. Well, this is an async operation. To read the body of the stream, we have to do that in an async manner using task of T in C#. But F# has its own approach to doing async. So we're using the async. Async is F# approach rather than task. And we need to convert a task of T into an async of T. So we do that with this async await task. And I'm using a pipe forward operator in F# to do that. So the pipe forward operator takes the thing on the left-hand side, so stream read to end async, and puts that as the very last argument to whatever you're piping into. So this is basically the same as doing let bang rec body 2 equals async dot await task, and then stream dot read to end async. If I can type. Okay, so these two lines are computationally equivalent. That's what the pipe forward operator will generate. But in F# programming, we'll tend to use the pipe forward operator to create a pipeline of operations, because let's say that I was passing something into readline async. I might have like, let's just go foo. We might pipe that forward into this function, which is then piped forward into there. Otherwise, you would then have like foo, and then it can start getting a bit messy.
Right. And I know, Aaron, I'm guessing you're using like font ligatures. So that's why
yes. So I'm
using line 37, it kind of merges them together.
Yep.
So you're pretty much using a vertical bar and a greater than sign.
Yes, it's a vertical bar with a greater than sign. Yes. Sorry, I forgot. I have not everyone uses font ligatures. Yes.
Okay.
My bad.
Yeah, I just wanted to make sure you didn't add like some super character to your keyboard.
No. I haven't extended my keyboard to do this. You don't need a custom keyboard to write FSharp code. It just looks like you do. So why is there an exclamation mark after this let, but there isn't one after this let? You might be wondering. Well, because this is an async operation, and we want to wait for the result of that async operation to complete. Similar in C#, you would do like var foo equals await some async operation. Well, let bang basically says this is an async operation and wait until it completes and then assign the value into request body. Whereas so that's on line 37, and then on line 39, this is just a normal variable assignment, or like we call them member bindings in F# because you bind something to that data. And then to make sure that this is treated as an async operation so that the compiler understands that you're doing async operations, similar to where you would decorate a C# member with the async keyword, we have this async, and then we open and close squiggly brackets around the block that we want to treat as async. This is, let me see if I can remember what, this is a, someone's going to correct me in chat. Computation expression, is that it? Someone in chat can probably correct me on that. But it basically says that inside of this block is something that's going to be done as async. Look for special things like use with a bang, let with a bang, use bang, do bang for something that returns no result. We can return with a bang, we can match with a bang, and then a few other things. But there's a bunch of other things that you can do instead of async. We'll see some of those when we look at Fable a little bit later.
So really quickly then, so when you're talking about doing anything inside of an async context, that exclamation point, for instance, on line 37, is something that is required whenever you're going to assign an async operation in addition to that pipe operation you showed us?
So if you want to assign an async and then await on the result of that async, so the same as you would do var foo equals await read to end async in C#. F# approach is the variable assignment. The way that we do the assignment is defining that it's an async operation, not the method call. That's probably the difference. It's on assignment, not on call. So we move. So we have a bang instead of await as the keyword, and we put that on the assignment of the binding instead of on the call to the function that is asynchronous.
Got it. So for C#, that's also like the exclamation point equals await, pretty much.
Yeah. So like this is equivalent to the C# of var rec body, body equals await stream read to end async.
Got it. Okay, that makes sense.
So that's the equivalent C# code there. Probably the last thing that's important to know when doing Azure Functions with F#, particularly if you're doing Azure Functions that require something that is going to be asynchronous, such as reading out of here or talking to a database and things like that, is that for it to be asynchronous, the functions runtime expects a task of T to be returned, whereas this will actually create a block of async of T. So the Azure Functions runtime won't understand what to do with that. It will ultimately just not call your function. So we then have to convert this from the F# async type system to a CLR task type system. So we can do that with async start as task. So we can convert C# task of T to F# async of T, and we can go the other way. So this is probably the thing that catches most people out when trying to do Azure Functions with F#, is they don't realize that you need to cast it to a task of T to do an async of operation in an F# Azure function.
Gotcha. Okay, and that makes sense. Because you did it. I remember you did it a little bit earlier up where you converted from a task into an FSharp async. So obviously when we're passing it back to the Azure Functions runtime, which understands task or task of T, then we need to, give it something that it knows how to work with.
Yeah, exactly. And there are other ways so that you can do better interop with C#'s async or task T stuff instead of using the F# async keyword. But that requires some a NuGet package that doesn't come in the templates that we've got from Microsoft for doing F# Azure Functions.
Got it. One of the things I love about looking at this particular code block is, like, I've written tons of Azure Functions before, never in F#. But like, as I'm looking at the code, like, I know exactly what it's doing, right? Because I've seen the C# template, I've seen the Python template, I've seen the JavaScript template. So kind of looking through this, like, this code logically makes sense as I understand what's happening here. So now I could use like context of me already understanding like what this is supposed to do, what it's supposed to look like, and kind of parse through the F# code to be like, oh, okay, I get it. I see what's happening here.
Exactly. Yeah. So while the syntax is a little bit different, we've got different, we got lets and use and bang operators and stuff like that. We don't have semicolons, then parentheses don't always appear. It's not that dissimilar. As you said, you can conceptually understand what's happening because you know what the code should be doing. And then it's just that mapping that mental model of, well, what are the different keywords doing and stuff like that. I thought so that's how we can create a function on the back end, but how do we then consume that function?
Well, let's see this.
Here is F# that will compile down to code that runs on React. So this is for these, which uses Fable under the hood as the compiler. And if you've done React programming before, this is probably not that dissimilar to what you would have used there. We're using attributes to denote what are React components. We're creating a function component that's got a name that doesn't take any props in this case, so there's no arguments to the function. We're using React state to create a count variable and a set count mutation function. Again, if you're not familiar with React, I will try and explain enough of it so you can understand what's happening in the code, but definitely check out React if you're more interested in client-side programming and F#, because that's the one the community has adopted mostly. But this variable count will contain the current count, and then set count allows us to update that, mutate the state. So we never reassign count. We always call set count, which will update that. And then we're creating React components which will generate HTML using F#. Okay, so we've got that. We've mind-bended enough with that. So we're creating a HTML div. It's going to have a H1, which has got the count on it. We're creating a button, which has the text of increment, and then an on-click function, which takes a like a Lambda callback, which then calls set count and increments count. That's just like some in-state stuff there. Or we've got this one here, which is going to call that Azure function. So again, we've got our HTML and we've got a button. We've got our button has some text, has an on-click. And here we're saying this is a promise. So in JavaScript, a promise is the way that we represent an async operation. And this is going to be using the fetch API to go out, call API/get message, and then it will then update set message with that. So you'll see that, so this is kind of like we're in the Azure function, we're doing like async, and then we could use let bang. The promise is basically telling the compiler, what does let bang mean in the context of this bit of code? It's not going to be calling, it's not going to be calling the like the async of T and stuff like that. It's going to be calling something specific around like JavaScript programming. Then this, it creates that, and this is called out to our API. It will get that, it will update state, and then we end up with our UI all up and running.
Right. So let's have a look. That might be familiar with. So for folks that might be familiar with React, they might look at it and be like, "Oh, okay, what is all this div stuff that's happening?" They might be familiar with like JSX, right, where you actually write the HTML in with the markup. But because this isn't JavaScript, this isn't JSX, what you're actually seeing is exactly what React does, right? Is React actually makes function calls for every HTML element you want to encompass it in, and you have to pass it the content, right? And so using Feliz and Fable, like what you're seeing is the actual function calls. So every HTML element, right? Like so div, button, different properties, all of those turn into function calls inside of this framework.
Exactly. Yeah. So they just convert into whatever's appropriate for that particular framework. So I know that we're kind of getting late in the show, and this is a very basic application. Like it's a template, right? It's not supposed to be particularly complicated, but I have built a slightly more complicated application that I wanted to show how we can really do stuff with FSharp and Fable, right? Kind of all these things together. So this is another project that you'll find on my GitHub repo. It's called on.NET FSharp Complete. And this is a trivia game built in FSharp end-to-end. It actually uses that same Feliz the template that we just had there before. And what I've got is an API which has a bunch of Azure Functions in it. So because it's a trivia game, I've started using a trivia game as my kind of version of a to-do application because throughout lockdowns last year, everyone was playing trivia online with their friends because we couldn't actually go out and see each other in person. So I was like, hey, I could totally build one of those. How hard could it be? And yeah, it turned out that it was a bit harder than I intended. But this is, so let's have a look at maybe the create game. This one here, it's an Azure function that is talking to Cosmos DB. So I've got a Cosmos DB input binding and a Cosmos DB output binding. So the input binding is going to get back all of the questions from our Cosmos DB instance that in turn is then being used to create a game where we're going to take a subset of those questions. So we've got a SQL query that's just happening in line, and then I'm binding that to a sequence. So this is similar to, this is essentially an IEnumerable from a C# analogy. And then I'm saying I'm just doing an anonymous type. It's just going to have an ID, and that's going to be a string. I'm then having to, then I'll create a game and then send that as an output of this function. So an out binding for Azure Functions. We don't, because this, the way that Azure Functions work, would use the out keyword in C#, which becomes an out ref in F#. So the type of this is out ref of game. So we're just logging out some information. Then we're using questions. I've got a little randomization function because I can't randomly select at a Cosmos DB level. I just have to pull back all the questions, randomize them there. We're then going to take 10 and then just grab the IDs. And then we're going to create a new game, which is going to just have an ID, which is the first 4 characters of a GUID. It's going to have questions. It's going to have no players and no answers because the game hasn't started yet. And then we're going to have some state and finally a model type. Now you'll notice that there is a backwards arrow. So that's the less than and a hyphen. This is how we can do assignment to something that is mutable. Right? So while F# is all about immutability, you do end up kind of like you will have to mutate some data somewhere, whether it's an out ref or whether it's a local mutable variable. You have to be explicit in the way that assignment happens. So it's not an equals operator. It is, I call it it's like a forcing operator. Like it's very clear that you're forcing the thing on the right-hand side of the operator into the left-hand side of the operator. So that's how we generate our game, return that out, and there we go. We can create a new game. And so, but this is then going to store this data in Cosmos DB. But this is then returning me a game that I might want to use client-side, and I want to do that in a strongly typed manner. So if I come down to my Fable application here, and then we're going to go to the home screen. I'm trying to remember exactly which screen it happens in. It is this one. So we have just a bit of our React code, which is going to generate a UI. We have just a header and some text. And then we're going to, on clicking the button, it's going to start the game, which is then going to do a post, We're not going to send any data on this post. So we use a generic type here saying that there's no data, a unit, which is equivalent, I guess, to a void in this case. And then we're going to return back a game record. So this is then strongly typed of game, which is a type that is the same type that was generated by my server. So my server and my client have used the exact same type. So if I was to change this, ID is now an int. My server will be told that this is invalid code now because it's generating a string instead of an int. My client will know that this is invalid code now because it's an int, not a string. Once the compiler runs everything, but let's not do that because I don't want to break anything. Instead, let's have a look at how this can run. Like, we've looked at some code, but let's see if we can actually run some code. And I'm going to pop that into our browser. Zoom this in a few. Hope that the demo is going to work. Fingers crossed. Wait, my camera's not on screen, so you can't see my fingers crossed. But hey, there we go. Let's play a game.
There you go.
I'm just going to pop open the network tab as well. So let's just zoom the network tab in so we can actually watch what's happening here. So I can click start a new game. It's going to call to that. Excellent. We have a look. We got a JSON payload back, which is the data structure we expected, which is typed by our server. Our client was able to deal with that. I can join the game. And then now we've got some more data back, and then we can see that there's other endpoints. These are all Azure Function endpoints that have been called that are returning data structures that are fully strongly typed. If I can find, here it is. There we go. I could even debug this. So where is my browser, localhost? I'm having some problems with some of the debugging, so I have to use another browser. I'll pop that there. Actually, no. Let's swap these over. Here we go. Zoom that in a touch. Okay, and this is in create home. Here we go. So let's put a breakpoint here, and we'll see if I can get the debugger running. And it looks like the one thing that I had that I decided to go off script for didn't seem to work. That's frustrating. Let's just try one more. Actually, close that. We go debug. Open link HTTP localhost 4280. No, we won't save that for later. All right, come on. I want to see some debugging. Because so this is generating source maps so that you can theoretically debug the FSharp code, and it doesn't want to look like it doesn't want to play nice for me right now. But yeah, you can get source maps for this, so you can debug the original FSharp code in VS Code that's running in the browser as JavaScript. That blows my mind to think that you can do that.
That's amazing.
Yeah.
So we do have one quick question coming in from YouTube. And this is from our friend Luis. All right, so Luis is asking, what does the source that gets served look like? Like, is it in JavaScript? So could you, I guess, like if you open the browser, or I don't know when it compiles locally, does it?
So this does compile locally. So Fable will just turn the FSharp code into JavaScript code. You then need to run some sort of like a bundle and minifier. So it's using the compiles to Equus. So this is the homepage. Sorry, this is that homepage with that start game button on it. You'll see that it's using the import syntax. So it's using ECMAScript modules for the way that we do all our dependency management and import external libraries and stuff like that. So if you're targeting browsers that don't support ES modules, you'll need to use some sort of a minifier. These templates that I've shipped for doing static web apps with React, so with Fable and whatnot, uses Vite, but you could use Webpack, you could use Rollup, you could use Parcel, you could use ES Build. How many more do I need to try? Basically, anything that can compile ES modules down to like JavaScript that runs without modules, just fine. But yeah, so this is the code that's running in the browser. So here's that homepage function. So it's using Feliz use static. Like because I'm familiar enough with JavaScript and with the original FSharp code, I can kind of make out what this is doing. So I know that this is using React state, and then it's generating me some input that is then unpacked from an array. There's a use effect callback, which is doing something around promises. Like, this is starting to get a little bit weirder, and but I can tell that that's returning a promise because there's the then keyword and stuff like that. We can see that it is create element with the H1, which has got the bit of text in it. And there's another button, which then has an on click. So it's readable. You would still need to understand the context of React and JavaScript to make sense of this, but it's not the worst compiled to JavaScript code that I've ever had to try and read and parse and work out what it's doing. But these all end up on disk. You'll see them here. So here's all the different pages. Here's our home page, so our application, and there's some. This is a pattern matching. So this is some. So the parse URL is a pattern match. This gets a little bit more trippy because JavaScript doesn't support pattern matching. But hey, I can work out enough of what if statements are doing, and there's a lot of tail calls inside of that.
Wouldn't it be nice if JavaScript had pattern matching in it, right?
There is actually a proposal to do pattern matching in JavaScript, but look, pattern matching is one of the things I absolutely love about FSharp. Right. And I suppose I probably love about C# as well, because C# has pattern matching.
Right. But I mean, just looking at the code from what you wrote to what got generated, and kind of going back to that question of, well, why would I write it in F#? So I think the benefits are kind of right there, right? Like, look at the amount of code you would have written otherwise versus just kind of writing a little bit of F# and having it generate like all that stuff for you. One thing I did want to ask you, so I'm looking at the structure in the Explorer on the right-hand side of the screen. So it looks like all of the JavaScript kind of gets dumped into, or gets dumped next to the file that's associated with. So if there's a home.fs, there's going to be a home.js and home.js.map.
Yeah.
Can you direct that output somewhere else? Like, or is that just kind of how things work?
No, so at least not that I've seen from Fable. I mean, I haven't dived into all the command line options. There might be a way, but generally what you would do is you would use a bundler that will then convert that. So what I've got here is, I'm just saying, like, here's the entry point is app.fs. I'm using Vite as a bundle for that. So it's just looking at that source folder. It's looking at that index HTML. It's finding that app.fs, and it's generating out a bundle. So if we have a look at the source code, actually, no, let's have a look at the deployed version, which is, I'm going to have to go to my GitHub for that because I can't remember what the deployed URL is. So this code is actually running live as well, if anyone wants to go and have a play with it. Here it is. We will jump into here, grab the URL, which is hidden inside of my build logs because I haven't copied it down yet. Here we go, Black Glacier, that's it. So when this actually is like deployed to Azure, we'll have just a single JavaScript file that gets injected into the page that runs. It's one of the, here it is somewhere. Yep. So here are there's two JavaScript files that get run. So these are the ones that are there. But I still have, because I have source maps turned on, I get at least the Fable compiled JavaScript. I need to have another look at why I'm not getting back to the full F# code. But this is run like a single bundle file at the end of the day in production. For local development, it might run a little bit different.
Gotcha.
Yeah, those are our files. That is a really horrible, massive bit of JavaScript that is run by our client in production.
Awesome. But kind of like what you said, like you could minify that, you could use like a bundler or whatever the case is, and then now we could ship a smaller payload over to the browser whenever we're trying to
exactly
production.
Yeah. So once it becomes a JavaScript file, it's then entirely up to you how you what you do with it and how you compile it into a single like releasable asset.
Awesome. Well, hey, Aaron, this has been amazing, man. I know folks in the chat have been really amazed about like some of the things that you've shown us. I actually kind of like what the code looked like when it actually came down to writing React with FSharp using Feliz. That seems pretty cool. I guess the one question I'd want to close with is when it comes to Feliz and Fable specifically, like, do they target specific versions of things? Like, is there a particular version of JavaScript and React that they target, or do they just always keep up to latest? Like, how do we track those things?
So it's so Fable will compile down to I think it's ES 2015 is its compilation target, but then you can use other like you could use a bundle like Webpack or anything like that to then compile down to even a lower version of JavaScript. Like if you only could support like ES5 because you've got the unfortunate scenario where you're still having to support like really old browsers like Internet Explorer or like specific mobile browsers and stuff like that. Once it becomes JavaScript, you can then compile it down even lower if you want. The same way as you would do if you're writing like just a plain JavaScript application or a TypeScript application. You can then like push it down even further if you need to.
Gotcha. Awesome. Well, for folks that might be interested in learning a little bit more or checking out your demos, like, do you have any other links that you'd want to share with folks? I know you shared your GitHub repo, but are there other things that you want to share with folks before we take off?
So, like I said, all this stuff that I've shown off today is built on top of open source projects. So, check out Fable.io. So that's where you'll find all the information around Fable. From their docs, they have a link to Awesome Fable, which is a bunch of links to other example applications, learning material, videos and talks, open source libraries, and stuff like that. So I definitely recommend checking that out. If you want to do like a web framework like Feliz, you can check that out on GitHub. The link to that is also on Awesome Fable. It's got all the documentation around how you can use Feliz to build web applications, the integrations that it's got with other open source frameworks. So if you want to use like Boomer, which is a CSS framework, or Material UI, like how you can do like a Material UI application in FSharp. It's got information around testing, doing tests like unit tests with Mocha or Jest, if you want to use those as test frameworks, and a bunch of other stuff there. I would really encourage you to check out the work that's done by these open source communities, because that's the stuff that has made made kind of what I've been able to demo possible. If you want to do Azure Functions with FSharp, I'll just pop up, not my LinkedIn, tags FSharp, because I don't remember the URL. Here it is. I'll pop this into, I'd say I'll pop it into chat, but I don't know how to pop that into chat.
You can put it in the private chat, and I can put it in the regular chat.
Okay. Well, I can put a QR code up on screen if anyone wants to scan that.
That sounds good too. Let's do that.
I'll just pop the QR code, but I've also just sent the link to you that you can send across. So this is a blog post I wrote about how to like get started with writing FSharp Azure Functions and the project templates that you can use to generate that, so you don't have to create like an empty file. We've got project templates for HTTP functions and a bunch of other common ones like queues, I think Cosmos DB triggers and a few things like that. I'm going to do some articles today and probably over the next week about the templates here, about that demo application that I've just shown off and how it works, and that kind of stuff. So keep an eye out on my Twitter stream or on my blog. You'll find a bit more information in the coming days. I ran out of time to get the blog posts pre-written for today.
Sure, no worries. Well, hey, Aaron, thank you so much for joining us. Really appreciate that. I learned a lot today. I'm sure folks in the chat, they've learned a lot too about just, writing FSharp functions and using Fable and Feliz to create like front-end applications with FSharp. Hopefully, folks, if you're watching still, definitely, like Aaron said, go ahead and try this out. let us know what you think about them. Let us know what you think about like the functions experience and even the coding experience when it comes to VS Code, and definitely let those folks that create those really cool open source projects like Phillip and Fable know what you think about them as well. With that being said, that's going to be it for today. Thank you all so much for watching. And we'll be back next week. We'll have Louise, actually. Louise is going to be here. He's going to be talking to us about, how we could use FSharp to do really cool things with, ML.NET and Apache Spark and all kinds of great stuff. So definitely make sure you come back next week, Thursday, and we'll have Louise on talking about a lot of that great stuff. Now, that being said, thank you all again. Appreciate it. And we'll see you all next time. Bye.
Thanks for having me on the show.